Hello and welcome back to a video series on MAT 1033 Intermediate Algebra. My name's Sean Perry. This is video number 5 in the series, more on the distributive property. So let's recall from some previous videos, what is the distributive property? The distributive property is a way of working around this parentheses here and actually doing the multiplication part first. The rule is that if you are multiplying a sum or a difference by some number, in this case b plus c times some number a, you need to multiply both the b and the c by a. Multiplying this a against both terms is called distributing. With a minus sign here, it would be no different. There would just be a minus sign here. Now, it's just as important to be able to go in the other direction, to read this equal sign from right to left instead of left to right. So here I've sort of flipped the equal sign to show that happening. A times b plus a times c. If there's a common a to both terms, that can be brought out front and multiplied against the sum in parentheses. And essentially what we've done is divided an a from both a times b and a times c to just get b and c, and then we put the a up front. This is called factoring out a. So let's do an example with numbers to kind of familiarize yourself with that process. Here I have 15 plus 18. Yes, I know you could do 15 plus 18 straight away. We're trying to see how the distributive property works here. So let's see what they have in common. What is a common factor to 15 and 18? And over here, I've written it's 3 times 5 to give me 15, and 3 times 6 to give me 18. So the common factor to both of them is 3. I could then write that common factor out front of the sum against 5 and 6. So notice 3 is playing the role of a before, and now it's being written up front. 5 plus 6 is 11. 11 times 3 is 33. So here are some critical notes. I want you to copy these as proof that you watched the video. You don't have to color code anything, but I thought it might be helpful. We go in one direction, multiplying the a against each term to get a times b plus a times c. This is called distributing. And if we are going from a times b plus a times c and going backwards to get a times the quantity b plus c, this is called factoring. Factoring in general means writing something as a product. And this is sort of a special case of factoring a common factor out of a sum. So now let's look at an example that has a variable in it. If I have 5x, 5 times x, plus 6x, 6 times x, well, there's a common x to both of them. I could pull the x out. I could pull it out to the right just as easily as pulling it out to the left because multiplication is commutative. And 5 plus 6, well, I know what that is. That's 11. And 11 times x, we usually write as 11x. So there's a shortcut to this pattern here. 5x plus 6x gave me 11x. If I notice that they both have just one x attached to them, then we can just add the coefficients, the numbers up front, to get the new coefficient 11, right? These numbers up front, the numbers multiplying by a variable term are called coefficients. Let's look at another example. Here I have 10x minus 3x is equal to 7x. Now the pattern works for subtraction as well. We could pull out the common x, take 10 minus 3 to get 7, and that would be 7x. It's very usual to not write the whole distributive property part of this, but it's why it's working. It's why we're able to do it this quickly. Now, these are called like terms. So we are getting closer to identifying this concept called like terms, where they both just have the same variable part, and we can then look at the numbers part in sort of a simplified light. We can kind of ignore the variables part. So we'll talk more about that later, but for right now, you should see that if we can factor out an x, we can just focus on the 10 minus 3 in this case and get 7. So now I'd like to look at another common operation that we do in algebra, which is called foiling, or distributing twice, or expanding something. Now, if we are multiplying a sum or a difference by another sum or difference, then the following pattern occurs. In order to multiply these two guys together, I could first distribute a plus b against both terms. So treating a plus b as one quantity and distributing that, I times c by a plus b, and I times d by a plus b. And I would get this. Now we could distribute the c and the d each inside the a plus b term. And what we would get are these 4 terms. So notice I had two terms times another two terms, or a sum of two terms times a sum of two terms. And now at the end, I've wound up with four different terms, all with different letters, different combinations of the original bunch. So these four terms, I know this is slightly out of order, but what we normally do is call this AC1 the first pair, right? They were first in each one of their parentheses. The outer pair, AD, these guys here, outer pair of the parentheses. Then the inner pair, B and C. That's another combination that we're going to get. And finally, BD, which is the last pair in the parentheses. This is an acronym. It's a shorthand. FOIL is a shorthand notation to remember that we need all four of these things. And yes, this is FIOL. We can switch around addition, can't we? So here are some critical notes. This happens so frequently, I want you to copy this whole thing down. I want you to say, what is the quantity A plus B times the quantity C plus D? And notice we will have a first term, AC, a outer term, AD, an inner term, BC, and a last term, BD. We need all four of these to make this happen. You are going to be doing a ton of these in this class. There will be lots of situations where we're multiplying two parentheses like this. In fact, later on, we're going to learn how to do this process in reverse. But for right now, let's just say, how do I do A plus 2 times B minus 3? Pause the video, in fact, and try to do this yourself. There's some hints in the color coding and see what you get. All right, your first term is going to be A times B. You're going to do A times minus 3, that's minus 3A. We'll do 2 times B, that's 2B. And then 2 times minus 3, that's minus 6. So we get all four of these in general. Here's another example. We haven't talked too much about squares yet. A variable times itself is sometimes written as the variable to the second power, or the variable squared. We will talk a lot more about this in subsequent videos, but for right now, this is really all you need to know to go with this problem and see an interesting fact that occurs between the outer and inner products here. Give this a shot and see what you get. All right, so the first one is going to be x times x, that's x squared. Then we're going to have x times minus 1, that's minus 1x. Then 2 times x, that's 2x. And minus 2 is going to be the last terms in product. Okay, so one of the reasons I color-coded it this way is both of these are like terms. They each just have an x. We have a minus 1 and a 2. If you factored out the x and you added the minus 1 and the 2 together, you would just get a single x. And in general, this is something happening very frequently when we have only one variable in each parentheses. In the previous ones, we had a mix of different letters, and so we wound up with terms that didn't contract. Here, I wind up with two terms that are like, and I can contract them into this single term. Okay, so now I have some practical exercises I want you to do. This is your praxis for this video. Pause the video at this time and give these a shot. Okay, let's see how you did. So the first one, we want to distribute the 4 against both terms. This is going to be a 12, and minus 2 times 4 is minus 8. How do I combine these into a single term? Well, factoring an x out of everything, I would have 10 minus 3 plus 7. Or just seeing these as like terms, I would have 10 minus 3 is 7, plus 7 is 14x. These don't have any common variables to them here, but they do have common factors in the 3 and the 6. 3 is 1 times 3, and 6 is 2 times 3. And so if I pull a 3 out, what goes here? Not nothing. I mean, I need this to be the thing which multiplied by 3 would give me 3. That's 1. And here I need a 2 to make sure that 3, if I were to distribute it back inside, would give me a 6. Finally, what's our foiling exercise here say to do? It says, let's do our first terms. That's going to be 6, 3 times 2. And then what about 3 times minus y? That's minus 3y. What about the inner? That's x times 2. That's 2x. And the last term is going to be x times minus y. That's minus x times y. We just write them together. This isn't the only order you could write this in. FOIL is a suggestion. It's just an acronym to remind you to get all 4 of these products, which you do need to get the right answer, but they need not be in this order. So if you got something in a slightly different order, that's fine, as long as your signs were the same. I put the signs here as sort of a guideline, so they are an important part of the answer, but really it's just addition and subtraction. We could change this order if we wanted to, and it would still be correct. Okay, that's it for this video. Thank you for your patience. Have a great day and good luck with your studies. I'll see you in the next one.